Okay, so here's our Chapter 6 method slides. These are actually the book slides. All right, and he starts out with a problem. And his problem was to find the sum of integers from 1 to 10 and from 20 to 30 and from 35 to 45 respectively. So what if we were going to write a program to do this? He says that you would have to write 3 separate loops. This first loop would add numbers from 1 to 10. The second loop would add numbers from 20 to 30. And the third loop would add numbers from 35 to 45. Now what's changing in these 3 loops? Only 2 things. This number is changing, that's one thing. It's changing from 1 to 20 to 35. And then this number is changing. But other than that, it's the same exact code. So when you have something like this inside of your program where you have the same exact code, but only a couple things are changing, that should alert you that maybe that this should be a function. And so then I wouldn't have to copy and paste this code 3 times. I just write a function and I give it new input and it should give me the right output each time. I would just have to give it those 2 inputs, where to start my loop and where to end my loop. By giving it those 2 inputs, it would give me the correct output. Okay? And that's what he's showing you right here, that these loops are the same. Okay? So we could combine these loops and make a function out of it. And here's that function and what it looks like. This is our first look at a function. All the functions we write in here will be public. And 95% of the time, when you're writing functions, they'll be public. What does public mean? It means that it's not private. What does private mean? It means that you're not allowed to use it outside of your class. And when you get into object-oriented design, public and private will make more sense. Just note that when we start our functions, they'll always start with public. You always have to write that word. And then we're going to write the word static. All of our functions in here will be static. Without knowing about object-oriented design, it's hard to understand what static means. But in a nutshell, static means that you aren't using any kind of data variables in your function. Once you learn about object-oriented design, that'll make even more sense about data variables. But just note that all the functions in here that we write will be public and static. The third part of your function is what's called the return type. One rule about functions, and this goes for all programming languages, is that your function can return one thing or nothing. Okay? You can either return one thing to the user when you call your function, or you can return nothing when you return your function. Okay? So if you are returning one thing, you have to tell it what that one thing is that you're returning, and in this function, we're returning an integer. And then you name your function. You can name your function whatever you want to name it, but traditionally we follow the standard of naming it something that it does or something that it returns. In this case, we're naming it sum because it returns the sum. Note that your function is lowercase to name. Java would let you compile it if it was an uppercase name, but we always lowercase our function names. That's a standard. Let's see, that's 1, 2, 3, that's the fourth part. The fifth part of your function are these parentheses. Okay, so whether there's something in the parentheses or nothing in the parentheses, you still have to put the parentheses. The parentheses tell the compiler, hey, this is a function. Now that I already kind of told you something about what goes in the parentheses. You can have nothing in the parentheses. You can have one thing in the parentheses. In this case, we have 2 things in the parentheses. And you can have up to 256 things in your parentheses. And these things are called parameters. So this is the first parameter, I1, and this is the second parameter, I2. Now these parameters are how our function knows something, because our function is encapsulated, meaning our function can't see anything outside of itself. It's like it has walls, and it can't see any variables that we don't tell it. It's its own little unit. And so when we want to send it information, we send it via these parameters. Okay? And we're sending it two things. We're sending it the first parameter and the second parameter. And when you send it these parameters, you have to tell it what type of parameters you're going to send it. If I tell it I'm going to send it an integer, I cannot send it a double. Okay? If you tell it that you're going to send a double, then you probably should not send it anything else but a double. Okay? Here's our part of our code that we're going to run in our function. So when we call our function, it starts at the beginning of this function, runs to the end of the function, and then stops. Okay? So what does this method do? A lot of times I use function, the word function, but remember that method means the same thing as function. Okay? In Java, the proper terminology is the word method. So when I run this method, what does it do? It makes a new variable called sum, and it sets it equal to 0. It then runs our for loop, and it sets I equal to that parameter that we sent in. So when I call it the first time, I will equal 1, or I1 will equal 1. Do you see how this, down here, this 1? I1 will then take on the value of that 1. And here's a little bit of terminology. Up here, when we define our function, these are called parameters. But when we call our function, this is called calling our function. What we send inside of the parentheses are called arguments. So this one argument with the value of 1, I1, the parameter, is set equal to the argument 1, value 1. The parameter I2 is set equal to the value of the argument 10. So it's like in the beginning, if I wrote something like I1 equals 1 and I2 equals 10. You copy those values into the parameters. So the arguments get copied to the parameters. So that when I'm running this for loop with this function call, I1 is 1, so it replaces it with the number 1. And I2 is the argument 10. So it'll sum up those numbers from 1 to 10. And then, this is an important part of your method, it has a return statement, and it returns an integer. Because we told it, hey, you can return one thing or nothing. It said, hey, I'm going to return an integer. So it returns the integer, which happens to be the sum. So you made like a little worker robot. A worker robot who says, where do you want me to start and stop my sum? I'll go ahead and sum up all those numbers in between those two parameters and then return that sum to you. So if I call that method with 20 as the first argument and 30 as the second argument, 20 is copied to I1. So I1 parameter takes on the value of 20. And the I2 parameter takes on the value of 30. So that when I call this method with those two arguments, my loop will start at 20. It'll go until it's less than or equal to 30. And it returns the sum from 20 to 30. This is a nice little example. It kind of shows you everything that you can have inside of a method. Note that our logic is all the same. We still have the same for loops and declaration statements. We've just encapsulated it inside of a function. So a method is a collection of statements that are grouped together to perform an operation. Okay. Here's an example of a method, another example. The best way to learn these is just to look at these examples. How many parameters does it have? 2. Note that it has 2 parameters. So that means I have to send it 2 arguments. Okay. What if I said x equals 5 and y equals 3, what will z equal? So 5 and 3 are sent in as my arguments. So 5 would be copied to num1 and 3 would be copied to num2. It would make this variable result. You'd plug in 5 for num1. 5 is greater than 3. So it would set that result to num1. Result equals 5. Comes out of here and then returns that number 5. Do you see how that function's working? It's actually pretty easy. If you've come this far in this class and you understand this logic, applying methods or using methods actually makes things easier because now we don't have to copy and paste that code. And it still runs the same way. All right. So here's some terminology. You can use this in your lab. In your lab, I ask you the names of these things because you kind of have to remember. These are called your parameters. A lot of times they call them formal parameters, but they're your parameters. Your method name, your return type. These are your modifiers. This whole thing together is your method header. So when they point to method header, it means the whole thing. And then this whole thing together is called your method body. From the curly bracket to the ending curly bracket, it's your method body. This is your return statement. Sometimes they call it your return value. And then your method signature is the name plus the parameters. The parameters list is your method signature. And method signatures become important when you start overloading your methods. All right. All right, so they kind of go through that in those slides. Let's try writing this, well, actually I wanted to try writing a different kind of method. He goes through that max method, and I'll let you guys look at those slides. I think the best way to learn this, though, is to program something. So let's get out of these slides and go and program something. And we can start with the max method. So let's start with their example of the max method. We'll make a min method instead. Now this is just for practice, so you can follow along with me or you can just watch this time around. We are going to do a class assignment today that I'll have you definitely follow along with me with. But if you just wanted to watch, this one would be okay. So that way you could just concentrate on watching and not just on trying to type really fast. Okay. Wake up, Eclipse. There you are. And I'm going to go ahead and make a new project. And in that project, I'm going to make a new class. Always name your classes with a capital letter. So I'm going to start out by defining my function. And this will be a method to find the min of 2 parameters. Okay. So remember how we always start these? They start with the word public. We're always going to make static methods. It'll make it easier when we're writing these types of functions without instance variables, just to make them static. And then we'll need its return type. Now you kind of looked at some of those methods and you read about methods in your book. If I was going to find or make a method to find the minimum of 2 parameters, what would be a good return type? Should I return something from this method? Does it make sense to return something? And it does make sense to return something. What should I return? The min. If I said, hey, what's the min of these 2 numbers, what are you going to tell me? the min. You always just say, hey, if I tell you two numbers, you're going to tell me back the min. So it makes sense that the return type will be that min, which could be an integer. Okay. I can name my method whatever I want, but we just use a lowercase letter, and we usually name it something it's doing. I can name it min. And then I have to put some parameters in there. I can name my parameters whatever I like to. And note that you name your parameters, and you can have up to 256 parameters. And then you just separate them by commas. Would you ever want a method with 256 parameters? Definitely not. But you are allowed to have up to that many. Yeah, if you had a method with 256 parameters, nobody would use it. That would be insane.
Why would they allow it so much?
In case you ever really did need that much. And 256 is just, that's how many memory locations it has. So it made sense that they have that many. And maybe if you were making some kind of system and you had that many inputs, I don't know, still, that would be kind of bad. Now note that it's red underlined because I'm not returning an integer yet. I told it I was returning an int, but I haven't said I'm returning an int. If I return an int, it makes him happy. Oh, yes, you're returning an int. Is that the right int I want to return? No. If you don't want that red underline there, just to make the pre-compiler happy, just put that in there. Okay. So I would just have an if statement in here, and I would just say something like, if num1 is less than num2, then just return num1. Otherwise, what do I want to do? Return num2. Note that I did this a little bit different than his slides, but this does the same thing that his slides do, just with less variables. Okay, and I think it's good to see it this way. There are lots of ways you could write this function. This is one way. And I'm going to run the debugger and show you how you can use the debugger to help you realize how these functions are working. Okay, this is called your function call, or calling the method, our method call. We've called methods before. Next int, next line, those were all methods. The POW function was a method. Remember, we've used methods before. If you ever see a lowercase name followed by parentheses, that signals to you method. This is a method. Because we made him a static method, I'm allowed to call him like this. If I got rid of this static, it would yell at me that I can't call him like this. Okay, so that's why we have that static word in there. Okay. I'm sending it 2 arguments. This argument's value will be copied to this parameter num1. And the argument 10 will be copied to num2. It'll plug in 5 less than 10, and it will return 5. So let me show you how you can run the debugger, also to kind of realize how these methods are working. So when we're first learning methods, I think it's a good idea to kind of see how they're working step by step so we can run our debugger. To remember when you're running the debugger, you need to have a breakpoint, and a breakpoint tells the debugger when to pause so that you could step through your code one line at a time. And so I double click anywhere in this margin area to put a breakpoint. And remember, to get rid of your breakpoint, you double click on your breakpoint, and to put a breakpoint there, you double click. You can have multiple breakpoints, but I'm just going to put one at the beginning of my method, which tells the Java virtual, well, it tells Eclipse that when it gets to this point in my code to pause and start the debugger. When I want to start my debugger, I just hit the little bug icon on my toolbar that says debug when I hover over him. It opens up the debug perspective, and it shows me where I am in my code. Actually, I should have put my breakpoint up here. So I'm going to stop him, and I'm going to put my breakpoint up here in main. So that way he'll pause before I go to that method. So notice I just hit the red stop button, put my breakpoint up here, and now I'll hit my bug button again. So here I am in main. It's going to call my method and pass to it these two arguments. I'm going to step into my method. So if you hover over those buttons at the top, there's one that says step into. That'll take you into your method, and you could see that num1 was indeed given the value of 5, and num2 was given the value of 10. I can even hover over num1 and num2 to see their values in the debugger. So this should be a true statement. I should get to this return statement. So I'll just step into. It does indeed say true. Go to that return statement. Returns me back to my system out print line, and now it can execute the system out print line. It's pretty okay, right? Kind of get how that's working. All right, I'm going to go back to my Java view, and let's write another method. A method that I thought we could write that's actually on your lab is write a method that takes 3 numbers and returns the average of the 3 numbers. So I thought I'd help you out. We'd write it in class today. Okay. So if I were going to write a method that takes in 3 numbers and returns the average of those 3 numbers, what would it look like? And I'll make it a new method. And I'll even put on here a method to find the average of 3 numbers. So what is my method going to start with? Everybody? Public, yes. What's the second word going to be? Static. Now it's going to find the average of 3 numbers. So my input will be 3 numbers, and my output will be the average. So I'm going to return the average. What should my return type be? Maybe not an int, a double. And the reason that I want my average to return a double is because he could actually have a decimal place. So if I had returned an int, I would have lopped off some of the decimals. So I'm going to have the return type be a double, because that's always what you want your output or what you're returning from this method. Okay. I can name him anything I want, but I'll go ahead and call him average. And so now I think about what's my input, what should be my parameters. My parameters should be what I need as input, and my input needs to be 3 numbers. So that means my parameters will be those 3 numbers. Now they don't have to be integers. I could have these be doubles as well. But let's just say I'm writing this and I decide that the user is going to type in 3 integers. So I'll have my parameters be integers. All right, how do we find the average? Yeah, there we go. Num1 plus num2 plus num3. Now note that I have my parentheses there, so order of operations will be correct. And And then I divide by 3. And then I can return this. Now I don't have to make this temporary variable. I could write something like this, and that would probably be more acceptable than writing that temporary variable. A lot of times in the beginning we write temporary variables, but note that this does the same thing and a little bit more efficiently because we aren't making that temporary variable.
I'm gonna ask you about ending the beginning. That I gotta go up to double.
Oh, yeah. Now note that we're dividing integers by an int. We are doing some int math. What should that be? Yeah, make one of them a double, then we'll be okay. Now note, without it being a double, it still let me do that because an integer can fit into a double. But we would get a logic error there, so we need to make one of them a double. He should be better now, actually. Do you have it look like this? So go ahead and test him. How do you test him? You call him in main. So make sure that he does actually work. When you hover over it, what does it say?
Once they do return already.
Oh, you just have to take away the AVG equal, that part there. So that way it's actually returning the answer. And oh, you just have to have return.
Yeah.
Instead of double. Actually, you could have had it, sorry.
Yeah.
If you had it this way.
My Control Z
is not working.
Yeah, I don't know why it lagged. It's like.
So you had it like this, so now you would just return AVG. And do it, yeah, right after that line of code.
Another thing, I can't do the Control I anymore. I did it and it just erased everything and I couldn't do Control Z, so it was soft.
We'll try to fix it after. Yeah, those are two ones that we need to have working, Control Z and Control I. So remember to call this function or to call this method. You would just put the method name in the parentheses. Note that we say you have to send it 3 different parameters. That means up here I have to give it 3 separate arguments. So I could give it the arguments. I don't really care what arguments I give it. Now note that I just hard-coded some numbers in here. You don't have to have just numbers be your arguments. Remember that I could have a variable be one of my arguments. I just hard-coded variables in here just to make it easier to write. But of course, you could replace those arguments with a variable. And you can even have your user type in these variables, use next in to gather that variable, and then pass them into your function as well. So you can use all that logic that we've learned so far. And adding methods just makes things easier because now we can organize these copy and pasted lines of code that we want to repeat. All right, some things to remember about methods. Let me show you this. We'll use this example even. Sorry. Note that I'm sending in this variable called number. I set them equal to 9 here. Okay. I pass them into this function called average. That means the average function down here. Num1 takes on the value of numbers, so it's like 9 is copied to num1. If inside of this function I change the value of num1, let's say I just Now note this function is no longer taking the average of those three numbers. I've changed it, but I'm changing it just to show a point. If I'm changing the value of that parameter in the function, when I come back up here to my main, so this is after my function call, and I print out that number, what will he print? Will he print 9? Or is he going to print 80? What do you think?
80? 89?
9. And the reason being is, when he takes that 9, it's like he's photocopying it to num1. So you actually have two separate variables. You have number and num1. Number, the value of number is copied to the value of num1, but they're still two separate variables. So when I change num1 in memory to 80, it does not change the value of number. So remember that when you're changing the value of your parameters in here, the value of your arguments that you sent do not get changed. Because it's like taking a photocopy of it. It copies it. Okay? And this is called pass by value. We're passing the values of these variables to our function or to our method, and then our method uses those values and not the actual variable. So those values are copied. That's an important concept, and that's called pass by value. And primitive type variables are always passed by value. So we're passing them by value. One other thing that you should know about methods. If I make a variable called my variable, I don't know, inside of this method, so inside of my average method, in between its curly brackets in its method body, I made a new variable called my variable, and I set them equal to 90. If I go into another method and I try to print out that variable, what do you think is going to happen? Did it do what you thought it was going to happen? Hopefully. He doesn't know who my variable is. Because that variable was declared inside of this method body, this variable is local to this method. That means he's created when this method is called, and he's destroyed automatically when the method ends. Yeah, he destroys him. So he makes him when the method starts, and then when the method ends, well, technically he's on the stack and gets destroyed, but we can think of it the other way. So, but the important point is that this variable is created here in between these two curly brackets. He only can live here. And outside of these two curly brackets, nobody knows who he is.
So we could, if we're out of the curly brackets, can we use like the same?
Oh yeah, definitely.
Like say we use my variable again.
Yeah, you can use him inside of any pair of curly brackets. And he's a totally different variable. This is a totally different variable than this variable, and that's okay. And that's called encapsulation. It's also called local variables. This is a local variable to this method body, or this block of code. Encapsulation means you don't care about what's written here. You just care that this, what this looks like, and that I could use this function, that it works. You guys want to make a programming problem? I think we're ready already.